So now we're going to do the second part of the Unit 6 Notes 2 video. So let's take a look at this word problem. It says that movie sales decrease each weekend after opening. The function E equals 49.9 times 0.692 to the W models the earnings of a popular movie. In this equation, E represents the earnings in millions of dollars, and W represents opening weekend. Graph the W equals 0, represents opening weekend. So we want to graph the function and estimate how much money was made for the movie opening weekend. Well, if W is equal to 0, that means that this is basically going to be our y-intercept, is how much it's going to make opening weekend. Okay, but we still need to graph it. So I'm going to do 0, 1, 2, 3, 4, and 5. Okay, so what we're going to do is we're going to plug 0 in right there. So in your calculator, you're really just going to do 49.9 times 0.692 raised to the 0 power. Now, when you do that, you get 49.9. Okay, so 49.9, that's how much money was made the opening weekend, is $49.9 million. Okay, so now let's go ahead and plug in the rest of it. So we're going to raise it to the first power, and we're going to get 34.5. And then we're going to take it to the second power, and we're going to get 23.89. And then we're going to take it to the third power, and we're going to get 16.54. And then we're going to take it to the fourth power, and we're going to get 11.44. Again, I've done these calculations out in advance. I do suggest pausing the video and making sure that you can get these numbers. And then here we're going to get 7.92. Okay, so let's go ahead and let's graph this. So what I'm going to do is I'm going to have this go by 3. So I have 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, 48. So just above that 48, I'm going to have my 49.9. So I'm going to go ahead and graph that in a different color just so we can identify it. So 49.9 is right there. Now 34.5. Well, I remember my oopsies was at 39. So then we have 39, 36, 33. So between these two, about halfway, is going to be my 34.5. Then I have 30, 27, 24, and here's my 21. So really close to 24 is going to be my 23.89. And then that's my 21. My 18, here's my 15. Just right above that, it's going to be my 16.54. Here's my 15. Here's my 12. So my 11 is going to be in between 12 and 9. And then my 7.92 is going to be just below that. So that right there represents the decrease of those movies after their opening weekend. Because if you think about it, once the film opens, it's really high the opening weekend, and then once people have seen it, the amount of people that go are going to decrease, which is why that's going down. So let's take a look at this one. So here it says, some people say that the value of a new car decreases as soon as it's driven off the lot. So this function right here, it's not letting me highlight, models the depreciation of a new value. So depreciation, that word means that it's going down, of a new car that originally cost $25. V represents the value of the car, and T represents the time in years after its purchase. So we want to estimate the value of the car after 5 years. Well, that works out perfect, because when we go through and do this, we're going to do 0, 1, 2, 3, 4, and 5. So once we graph the function, we can use 5 to figure out what the value is going to be after 5 years. So what we're going to do is we're going to take this equation. So we have 25,000 and then times 0.82. So the first thing I'm going to do is raise it to the 0 power. Well, 0.82 to the 0 power is just going to be 1. So my initial value is going to be 25,000. Whether it looks like it or not. Okay, then we're going to raise 0.82 to the first power. So 25,000 times 0.82, that's going to be 20,500. Okay, then 25,000 times 0.82 squared is going to give me 16,810. Then 25,000 times 0.82 to the third power, that's going to give me 13,784. Okay, then 0.82 to the fourth power times 25,000 is going to give me 11,303. And then 25,000 times 0.82 to the fifth power is going to give me 9,268. So the value after 5 years is $9,268. So now we just need to graph this. So I'm going to go up by 2,000s. So remember, whenever you change your scale on these, you need to make sure you make a note of it to me. So we have 2,000, 4,000, 6,000, 8,000, 10,000, 12, 14, 16, 18, 20, 22, 24. So 25,000 is going to be halfway in between those. So I'm going to go ahead and change up that color again so we can see it. So that's going to be my 24,000. So then what we want to do is 1 and then 2,500. So that's going to be at 20,000. So here's 22,000, here's 20,000. So just above that is going to be 20,500. So then the second one, 16,810. So if this is 20,000, this is 18, here's 16. So this is going to be just a little bit above that 16,000. Then 13,000. So here's 14. 13 is going to be just probably in the middle about there. Again, we're just guessing or estimating, I should say, with each of these. So this is 12,000. This is 10,000. So 11,000 is going to be about right there. 9,000 is going to be about right there. So this is going to be slowly sloping down. But if you think about it, after 5 years, your car is only worth $9,268. That's less than half of what you bought it for. And this is actually a pretty realistic picture of what depreciation looks like. So now we're going to identify if charts display exponential behavior. To distinguish if a chart displays exponential behavior, what you're going to do is you're going to take one number and divide the number before it. So I'm going to do 25 divided by 10, and I get 2.5. And then I'm going to do 62.5 divided by 25, and I get 2.5. And then I'm going to do 156 divided by 62.5, and I get 2.5. So I do know that this is exponential because each of these numbers are the same. If one of them was different, then the equation is not exponential. So let's go ahead and graph this. So what I'm going to do is I'm going to have this going up by 10s over here and over here. Okay, so we're going over 0 up 10, so I'm going to plot that there. Over 10 up 25, so I'm going to plot that there. Over 20 up 62, so I have 10, 20, 30, 40, 10, 20, 30, 40, 50, 60, and just above that. And then 156.25 is going to be off our graph. So that's our exponential function. If we were to graph it and it wasn't an exponential function, it might look more like a line, okay? Or it could just be a bunch of random dots placed all over the place. So now let's take a look at number 10. Does the exponential chart show exponential behavior? So again, we're going to divide. 0.5 divided by 1 is 0.5. 0.25 divided by 0.5 is 0.5. 0.125 divided by 0.25 is 0.5. So yes, it is exponential because we have each of those numbers. So I'm going to do 1, 2, 3, 4. So I'm going to have this be 1. So then this is 0.25. And the next is 0.5 and 0.75, okay? So we're going over 0 up 1. Then we're going over 1 up 0.5, so I'm going half the way to 1. Over 2 up 0.25. Over 3 up 0.125. So that's going to be our exponential function. Again, we're not crossing this line right here. We want to make sure it kind of comes down and sits on top of it, okay? So that includes your note video for Unit 6, Notes 2. Please let me know if you have any questions. Thanks for listening.